Good afternoon, everyone. How is everyone today? Hope you had a wonderful morning with a very good breakfast. So, here we are again with another lecture on sorting. So far, we discussed about you know different sorting algorithms. Um, think about for a second. What if we can sort in a linear time, right? Uh, isn't it good? Wouldn't be wonderful that if we can sort in linear time? But it's very difficult. However, if we have our inputs in some um, in some way, or the inputs have some information which we can make use of, can we do a better job of sorting? Yes, sure we can. So here we have another kind of sorting algorithm called counting sort, which assumes that each of your n inputs, right, is an integer first of all, and those integers are in the range 0 to k, where k is some integer. So let's say you have input sequence and whose maximum your input sequence of 30 numbers, and 30 numbers maximum value is say 15. So all the numbers in your sequence fall in between 0 to 15. Okay. So counting sort determines that fact that for each input element, x, the number of elements less than x. So that fact the counting sort uses. And how it uses that, okay, if I know how many elements I have less than x, okay, then I can know the correct position of x in the sorted array. Good. However, if you have more than one elements with the same value, then we need some extra storage, or we need some other way to deal with that. We will see in a second. Uh, time complexity for this algorithm is order of n, linear time, provided that we have the condition that the inputs are integer, okay, and there is a fall within some range. Okay. Now we need the extra storage here. Why do we need extra storage? First of all, we need to determine that the each input element x, how many elements are less than x. So we need some extra storage for our calculating purpose, or intermediate storage. Then we need another storage, one array of the same length, to hold the sorted values. Okay. So that's the overhead of this sorting. Now let's say how we can do that. This is a simple algorithm. It takes the input, A, your original unsorted array, B is your sorted array, and K is the information that this is the integer. All the elements in the A would be less than K. Okay. Now let's say that we initialize another array C whose length or size is equal to k for our temporary storage to determine the fact that how many elements are less than or equal to k in our input array A. Okay. So we initialize all the elements in array C equal to 0. Now this is interesting, line number 4. Okay. For j equal to 1 to a dot length, okay, for each element in your input array A, we say that C position of aj equal to C of aj plus 1. So what it does that after executing the step number 4 and 5, your array C will have number of elements equal to I. Okay. So how many elements in your actual array A are equal to I? Okay. Now after doing that, we loop around once more for I equal to 1 to k, and we just actually add the element at position I with the previous element, so that the C or our array C, each element, the element stored at each position will have now contains the number of elements which are less than I. It means that how many elements are less than or equal to I in your actual input array A. And after that, once we have, so at this point, after line number 8, we have the information that how many elements in A are less than or equal to some integer which lies in between 1 to k. And line number 10 to 12 is just, after determining that information, we are just storing the value in B at a correct position. How we can do that? Very simple. For example, A is your given input array, okay, at position number 1. So this is the index I, okay, or let's say index j. 1, 2, 3, 4, 5, 6, 7, 8. For C, it goes. So at this point, we are here basically at step number 5. Input array is given 25302303 unsorted manner, okay, and C, after executing this step 4 and 5, we have now the C contains the number of elements equal to I. For example, C0 has 2. It means that how many elements are 0 in the array A. So if we say A, so 0 first, 1 and 2. 2 elements are 0 in input array A. So we have here 2. Now let's go to the position number 1 in array C. It has 0. It means that now let's look at the input array A. Do we have 1 in input array? No, we don't have 1. So we have 0 here, okay, no element. Now in the same way, Let's look at this C of 2. We have 2 here. It means that how many elements are equal to 2 in our input array? So let's count it. 1, 2. So we got it 2 here. Okay. In the same way, so we complete this whole array C, which contains some information about the values which are in input array A. Now we go to the next step number 7. For I equal to 1 to k, for I equal to 1 to k. So we are going from 1 to k. C of I equal to C of I plus C of I minus 1. So C of I is 0. Okay. So let's go. So C of I here is 0. Okay. Plus I minus 1, that is here 2, right? So 2 comes here, equal to 2. In the same way, let's look at the position number 2 when the I will be 2. So 2 means 2, C of 2 is 2 plus I minus 1 means 2 minus 1 is 1. So at 1 it's 2, right? So we got it 4. In the same way, 3. So at the position number 3, what we have in C? C of I has 3 plus C of I minus 1, which we already have now 4, 7. So we complete the whole array. Now the C array contains information, little more information, means that how many elements are less than or equal to I, where I is any position in array C. So let's say position number 0. Okay. So how many elements are less than or equal to 0 in input array A? So 0, let's see 0. 1, 2, the 2 elements. Okay. Now let's look at, for example, 3. Okay. C of 3 is 7. Okay. It means that we have 7 elements which are less than or equal to 3 in input array. Let's count it. 2, which is less than 3. Okay. 1. 5 is greater than 3, we don't count it. Then 3, yes, so we got 2. Then 0, yes, 3, 2, yes, 4. Then at position number 6 we have 3, we count it 2, 5. And then position number 7 we have 0, we count it 2, 6. And position number 8 we have 3, we count it to 7. So we got it 7 here. Good. So C will have now more information. Okay. Now we are here after executing step number 8. Our C looks like this. Okay. Now our job is simple. We use this information which we have in C to sort the values in input array A. How we do that? Okay, let's say this loop. For j equal to a dot length down to 1. So a dot length means that input array A, how many elements are there? There are 8 elements. Okay, so 8 down to 1. Okay, so first when the loop will execute first time, what the j will have? J will have the value 8. So here what it will have? B. Okay, then we have C, okay, then we have A, and J value would be 8, okay. What it will have? It will have B, C. So what would be A of 8? A of 8 is 3, okay, C3, right? Now let's look at C3. At C, value of the C at position number 3, okay. So 0, 1, 2, 3, we have 3 here. So C3 is 3. So we finally got B3, and B3 is equal to, so remember B is our array which will have the sorted values. So at the position number 3, we will have A of j. So A of j is A of j is 8, okay. A of 8 is 3, okay. Now sorry, here C of 3 is this one. C of 3 is 7, okay, because now our array is changed, so this becomes 7, okay. So B of 7 is equal to A of 8 is equal to 3. So we got the position of 3 in our sorted array, which is 7. Simple. And then when we got this position, we decrement -1 from C, because now we know that we have placed one element in a sorted array. How we can see pictorially is that this way. Initially B doesn't have anything. Now you have got the position of 3 in sorted array, which is 7, and you have decremented one value, okay. Isn't it very simple? Let's look at few more steps, okay. We are at here step number 10 to 12, and now we have executed a dot length. Now we are executing a dot length -1, okay. Same principle we're gonna apply here as well. B C. Now A of j would become 7. So A of 7 is equal to A 7. Okay. Now what is the value of a of 7? A of 7 has 0 value. Okay, so we put it 0. Okay, now what is the value of C of 0? Okay, C of 0 has value 2, so we put it 2 here and it's 0, and after that we decrement 1 from the 2, so here new value of the C will be 1. Okay, so we got the position, we got the element at position number 2 in our sorted array B. Okay, pictorially we can see like this, and we decrement 1 from the C because we know that now we have placed one more element in the sorted array. Good, isn't it simple? Let's take one more step further, and we got 3 at position number 6. In the same way, in the end you will get the sorted array B, which is shown here 0 0 2 2 3 3 3 5. Isn't it very simple? It's a very simple algorithm. See, so always remember, when your input has certain information, or you can make use of the information in your inputs, you can do a better job of sorting. Okay, this may not be applied in every case, but yes, when you have more information and you can arrange your input in such a way that you know in advance that my input key would not cross to this integer number, you can make use of this kind of sorting, provided that this has the extra overhead of storage. See, here we are using array B and array C. This is the extra overhead. Okay, good. So thank you guys. This was another short video lecture on counting sort. If you need private lessons, you may contact at hr@leprofessor.org. Do not forget to subscribe LeProfessor YouTube channel. This helps to keep you up to date with the latest videos. And thank you for subscribing my channel. Have a wonderful day.